Hi, I'm going to show the implementation of decision tree algorithm. Decision trees help in the classification of a data set. The core idea is to build a decision tree that will select the features from the data set to make the decision. Decision is simply the class variable that is defined at the end of each row. So there are multiple ways to build a decision tree. One of the ways ID3. This is the document which explains how the ID3 algorithm works. So ID3 uses entropy and information gain, has additional attributes on the top of the input attributes to build a decision tree. So these are the normal attributes which we are taking ABC, and this is the decision attribute. We are calculating the entropy of the data set, each attribute, and information gain of the attribute. Depending on that, we are going to build a decision tree. So uh, let's open our program. This is our project. First download the zip and extract the project from the zip and open it in the Eclipse. You can just import the project folder in Eclipse, and this is the input data which we are taking. These plus and minus signs represent the decision attribute, and these all are normal attributes for which we are going to calculate the entropy and information gain. Entropy is the measure of how different is the data set or how varied the data set is, and information gain is the decrease in entropy when we split the data set based on an attribute. So here the core logic is we have to minimize the information gain, that is maximizing the entropy to build a decision tree. Generally, decision attributes become the leaf nodes of the tree. The program here has to traverse the decision tree based on the input attributes to arrive at a decision. So to run this program, first we have to click on the first we have to click on the project, and we have to build the path. Here is the option to build the path and configure build path. Here the first thing is you have to check if the org the Eclipse SWT is added. If it is not, you have to add it and you have to apply it. Now go to libraries and check if the jar file which is present in the project Vekas table jar file is present. If it is not present, then you can add the jar files here and you have to apply and close. Now we can go through the code and we can just run it. GUI Java consists of the code, UI of UI of our project. All the code is present here, which is the UI of our project, and driver Java have a code to calculate the entropy and information gain of each and every attribute in the data set. Here, here are the calculations to find the entropy of an attribute and information gain of attribute. And data node.java consists of the code which is used to build the tree. Here we can give the node, we can give the root node, and using the entropy and information gain which we calculated from driver.java is used here to build the leaf nodes and child nodes and parent nodes of a decision tree. So to run the project, go to GUI.java, right click on it and just click on run as Java application. And here we get this. Here we need to upload the input file. Data.txt is our input file. When we upload the file, we have to select the percentage of training data set. Normally we give 75% to 80% or 70% of the training data set. So let's give 75% as a training data set, and let's build the tree. When we build the tree, we can check in the console that we have 50% of accuracy for this model. Here the information gain is calculated for all the attributes. There are A, B, C, 3 attributes. For now we are splitting, we are taking attribute B as the splitting attribute, and for attribute B we have the children nodes. For data IDs, edge 1 is 1, for data IDs edge 2 is 2, 3 and 5, for edge 3 is 4. This is the data ID 4 is the leaf node of the tree. And similarly, for now again we will take the splitting attribute from the remaining attributes A and C. Here the information gain is calculated, and we are taking splitting attribute as A, and data IDs for that are 3, 5 at edge 1, and at edge 2 it is 2. So similarly, next we will be taking the information gain for C, that is attribute 3, and then we're gonna calculate the data IDs. For edge 2 we have 3 and 5. So this is how we are traversing the decision tree, and the accuracy for this model is 50%. We can even check for different training data, and we can gain different model accuracy here. So this is how we are building a decision tree using ID3 algorithm, which basically works on minimizing the information gain. Information gain depends on entropy. Thank you.